So what's up YouTube, and today I'm solving a problem of governor, Hartnell governor. Now it is the 13 number problem. mm, I've seen the similar type of problem in the internet. When I searched for this problem, I was not able to solve this problem by myself at first, and then I searched for this problem and I found this similar type of problem. And the problem was, you see the answer here, it is 28.96 Newton per millimeter and 472 RPM. But in the same problem that I found on the internet, it was not like this. It was 23 Newton per millimeter and 407.75 or 76 RPM. So I tried to solve this using the theories that I've studied, and I was failed to solve it like this. The answer was not even close to 28.96 Newton per millimeter and first meter. So then I tried again and again, and I finally was able to solve this problem. But I solved it, and the answer was similar to the answer that I found on the internet, that is 23 Newton per millimeter and 407. But I was never near to this kind of this result. And this book, if you're wondering what is, this is the book of Theory of Machine by R.S. Khurmi, and I searched for the solutions of it in the internet, but I was unable to find it. And if I even found it, they wanted a credit card number or something like that, and it was more complicated, so I didn't do that. Now I solve it like this, and everything is given here. The M, the big, the large M, mass of the ball, mass of the sleeve, and minimum radius of rotation, minimum RPM. So first I did what I found out the FC1, which is the centrifugal force for lowest position of the sleeve, or lowest position of the ball, and I found that. Then the H, the sleeve lift, the difference between the maximum minimum position was given, that is 10 millimeter, and I found out the R2, that is the maximum radius of rotation when the ball is rotating, the maximum centrifugal force, and then the corresponding R2 for that. Then I found out FC2, which is 566 Newton, and then just performing this equation, we got S, which is the stiffness of the spring, that is 23 Newton per millimeter, or 23,000 Newton per millimeter. And then we have calculated. So now it is said that the spring during an overhaul, the spring was compressed 2 millimeter more than the correct compression. So since it was compressed 2 millimeter more, then the H1 will be changed or increased by 2 millimeter. So first I determined H1 by using S, and then I added this 2 millimeter extra compression to H1, and I determined the new S1 dash, that is the force of the spring due to 2 millimeter extra compression. And after that I just reversed the process. I determined FC1, then I determined what can I say, the omega 1 square, then N1, and you can see the results are identical. The problem that I found on the internet and this result is identical, that is 407.7. Now I think that the result of this book is wrong, definitely, because the stiffness of the spring is always constant. No matter how much you compress it or expand it, it will be constant in between the elastic range. So I think this result is totally wrong, and I was unable to go even close to it. I think they have made a mistake. So and I think this one is the correct one, the 23 Newton per millimeter and 407. And I don't know, please let me know what you think, or if you have solved it like this, please uh, just tell me how you did it. And thank you for watching.